Greetings, fair children. Friday night, let's look at some practice problems you need to be able to work through and understand for the upcoming quiz early next week. Let's take a look. Today in class, we went through these types of problems. We started practicing some basic radicals, both square roots and working out roots on numbers that aren't perfect squares. I said that wrong. Perfect squares and numbers that aren't perfect squares, taking roots of both of those. So for instance, you know what? No, yours are first. You do 1, 2, 3 on the left. Then I'm going to do some examples that kind of add on to that in a minute. You start with those 3. Go. All right, number 1, that's just a perfect square. 9 times 9 is 81. So it's as simple as that. Number 2, there isn't a perfect square for 28, so we're breaking them down and looking for what's inside. That's a 7 times a 4, and the 4 is 2 times 2. 4 is a perfect square. We can take the square root of that. Okay, and whether you see it as the 4 or you see it as the 2 times 2, either way it becomes the 2. What's left inside is that 7 because we can't take his square root. Number 3, working with some variables. If we expand that x, there's a group of 3 x's. The cube root of that is an x. The remaining 2 x's can't get out. They stay underneath, and we've got 7 y's. 7 y's make one group of 3, 2 group of 3. So those 2 y cubes, we can take the cube root. The first group is 1y. The second group of 3 is a second y, which makes it squared. And there's 1y left that can't get out. All right, hope that's making sense to you guys. Let's look at some examples on the right-hand side that are just adding to what you just did. For instance, those are the same problem, except I have a 3 on the front of mine. So the radical 28, I'm going to do the same exact way you did. It's going to be 7 times 4, and we see that perfect square. That 4, or the 2 times 2, however you want to look at it, that's square root 2, and the 7 stays inside. But we've got that 3 out front. 3 up front is multiplying with the radical 28. So we need to include him with the problem, and we need to do any multiplying we can do. So now that we've pulled the 2 out, that 3 is still here, and he's still on the front. Now we can actually do that multiplying. Back here at the beginning of the problem was also a multiplication, but there's nothing the 3 can multiply with because that radical 28 isn't simplified. So we just leave it there. 3 radical 28, you could kind of think of similarly to like a 3x, in the sense that we're sticking them together, but we're not finishing the multiplication. It's kind of there waiting. And now that we get to this point and we simplify the radical, we pull that 2 out, we can actually multiply something with that 3. So it ends up becoming a 6 radical 7. So the work you did, just like you did on these first problems on the left, you do it exactly the same. And if there happens to be something out front, that's just going to get multiplied with any of those values you do pull out. So on the 60, I'd look for what I can break it down into. I know that's a 12 times 5, and the 12 is a 4 and a 3. So at that point, I can either see the 4 as my perfect square, or I can break the 4 into 2 times 2. If I see a pair of something, I know I can take the square root of that. So I can pull those 2's out as a single 2 when I take their square root. 3 and 5 are my leftover pieces. Those have to go back together. 3 times 5 is 15. And they stay under the radical. This guy's just distracting. He needs to move out of the way. Okay, so I'd be done. 2 radical 15, except don't forget that 5 was out front multiplying, and now he's got something to multiply with. So don't forget to bring him over. And I can't quite separate that like I'd like to. So let's just move our 2 over a little and bring over that 5. And he's waiting to multiply. He now has an actual value that came out of the radical 60. So we can multiply that together, and we get that 10 radical 15. The radical simplifying step is still most of the work. We're just adding that little piece at the end. If there already is a coefficient out front, you can now multiply that with any values you're able to pull out. Let's just do it a couple more times to make sure you guys are getting it. My 48, I just look at it as a 6 and an 8. The 8 is a 4 and a 2. 6 is a 3 and a 2. So I'm just looking, those are all my factors, I'm just looking for any pairs. There's a 2, there's a 2, so that pair of 2's comes out. There's my square root of 2 I can pull out. The 3 and the 4, there's only one of each. Those have to go back together to make a 12. Okay, because those factors, they go back together. And that's 2 radical 12. I'm done if I didn't have another value out here, which I need to bring down. And again, now I can multiply it because I actually pulled something out of that radical. So now it's going to be negative 18 radical 12. I simplified out the radical, and then I multiplied whatever I pulled out with that negative 9 coefficient that was already on the front. One more time, make sure you're getting it. I don't even know what's inside an 84, so I'm going to guess like you guys. I'm going to say 2 times something, because it's an even number. That would be 42. I'm just taking that number and breaking it in half. 42 is again an even number, so now I'm down to 21. 21 is 7 and 3. There's that pair of 2's that I can pull out. Okay, they're my perfect square. They come out as a 2. There's my radical. I've got a 7 and a 3. They make that 21. They can't come out, so the 21 stays underneath. And then don't forget that 7, if we had it, needs to be multiplied. So final answer is 14 radical 21. All right? All right, there's a set for you guys to try. You guys give it a shot, and I'll follow after you. You know the drill. Go. All right, let's see how you did. Breaking down that 44 and 10. 2 and 2, there's our perfect squares, and then we have another 2 and 5, so the square root of those 2 2's, or the 4, is the 1 2 that comes out. 2 times 5 or 10, that didn't break out. There's only one of each of those, stays inside. And then don't forget that 8 multiplies with whatever did come out, so we end up with 16 radical 10. All right, let's do the next one. 72, I know that's 9 times 8. Now, this is a good example because 9 is 3 times 3. So I might see the 9 and think I'm done. Pull out my 3 and I'm good to go. But inside of 8 is 4 times 2, another perfect square because 4 is 2 times 2. So this problem has a pair of 3's you can pull out as a square root 3, a pair of 2's you can pull out as a square root 2, and then all that's left is the 1 2 that has to stay under the radical. 3 times 2 is 6. So it turns out we could actually pull out a 6, which makes sense because 6 times 6 is 36. So we could have factored the 72 as a 36 times 2 and saw that 6 from the beginning. Either way, if we do our work correct, we still get the right answer. But don't forget, bring that 9 down, multiply that. So our final answer is actually 9 times 6 is 54 radical 2. All right, last one, 75. I know that's a 25 times a 3. 25 is 5 and 5. There's my 2. The 2 of something that makes a perfect square. Taking the square root of those 5s gives me 1 5 on the outside. All that remains is my 3. Bring over that 7. And we end up with 35 radical 3. All right. There's your guys' homework. Handful of different problems here. We've got some exponent review and some various radicals. Give it a shot. I'll go ahead and run through these as solutions after you're done. Go. All right, I'm just going to write these out with minimal talk. Subtracting those is a negative. I'm going to have to get rid of that later. Those guys, I'm not going to subtract because they are negatives. I'm going to move them to their new locations first. So the y3, y2, to get rid of their negatives. And don't forget the whole thing is still raised to the 4th power. Now, I'm going to subtract the 3 minus 2 is y. So I've actually got, and I'm going to move that x. Let's do that step right now as well. Let's move the x down to get rid of its negative. So we've got an x2 on bottom, and then y3 minus y2 is a y on top. Take that all to the 4th power, and we end up with y to the 4th over x to the 8th. Okay, next one. Distribute that 4, and you could deal with the negative first. Either way is fine. P to the 16, m negative 12, and an n to the 8. That m is going to get canceled out, and then I'll just bring this stuff down. Okay, now I'm going to rewrite it to deal with those negatives. I've got p to the 16 is going to stay on top, but that p to the negative 3, he is going to go to the bottom. My m to the negative 12, he is going to go to the bottom and become positive. And the n's stay on top. Okay. So to be clear, that negative went to the bottom, that negative went to the bottom. Everything else stayed on top. P13. N10. All over m to the 12. Right. 32, let's see, 2 and 16, 2 and 8. There's one pair of 2's that comes out. The 8 is a 4 times 2. Man, there's just a lot of 2's here. There's another 2 pair that comes out. And of those 5 total 2's we found, 1 is left by itself. And don't forget there's a 6 that has to multiply with both those 2's we pulled out. 6 times 2 is 12, times 2 is 24. Radical 2. We are definitely going to need more room. $125, I see that's a 25 times 3, and there's my perfect square. Pair of 5's comes out, leaves that 3 underneath. Don't forget that 8, we end up with a 40 there, and radical 3. All right, now it's a little easier. Remember, that's an invisible 2, so x to the 5, we're just taking out pairs of 2's. One group of 2, two groups of 2's. There's one x. There's the other x. We'll put those together in a minute. One x is left underneath. Y7, same idea. One group of 2y's, take its square root. Another group of 2y's. Another group of 2y's. And 1 is left underneath. Now we'd rewrite this stuff. X times x is x squared. Y cubed. And notice the shortcut. We should be getting to the point where we can see if I have x5 and I take groups of 2 out, I can take 2 groups of 2. Okay, that's where that comes from. 2 groups of 2 is 4 out of the original 5, which leaves 1x underneath. If I'm taking groups of 2 out of the y, I can take 3 groups of 2. There's the 3 groups of 2 I took the square root of. That's 6, 3 groups of 2. And 1 is left underneath the y. Now if this helps, by all means keep doing it. Do what you need to do. And then just don't forget at the end to keep that radical xy. There you go. All right, P8, we're taking, it's a fourth root. We need groups of 4. So an 8 breaks down into exactly 2 groups of 4. There's the 2 p's I can take out, none are left underneath. M's, we only have 1, not 4, so M stays. N, I can take 1 group of 4 out of the 7, so we can see it like this. Out of the 7, we took 1 group of 4. Its square root brings out 1n on the front. You could also say that there's 7 total n's. Take out 1 group of 4. That leaves 3 that stay underneath. And that 1 group of 4, when we take its fourth root, that's the 1n up front. Put that all together, we got a p squared n mn cubed. All right, guys, see ya.